Sapienza University of Rome, and I will chair this first subsession during the afternoon session. Today in this subsession we have 3 papers. Presenters have 15 minutes plus at most 5 minutes for questions. If you want to ask questions, please write them in the chat or raise your hand at the end of the author's presentation. So we can start with the first presentation. Matteo will present his contribution on the complexity of resource controllability in business process management. Matteo, the floor is yours. You have 15 minutes.
Yeah, thank you. Thank you for the presentation. Thank you for the introduction. This is a joint work with Professor Romeo Rizzi and Professor Tiziano Villa at my same university. And it's about theoretical complexity, computational complexity study and analysis on resource controllability in business process management. So this is the main contribution, and let me just minimize this. Okay. And the outline of this quick presentation is really simple. I will introduce a formal model to allow to reason about resource controllability, which is a field and a set of techniques to achieve a resource allocation under a few sources of uncertainty in business process management. We'll see in a little while. And then define the corresponding decision problems for consistency and controllability depending on the kind of process that we are looking at. And then summarize the complexity results, and then discuss conclusions and future work. Okay. As a starting point of this work, we considered acyclic business processes. So this is a very well known fragment of BPM, and that every one of you knows very well. So we went for a structured approach in which we consider the process blocks, in which we have a unique start and a unique end, in which we have terminal symbols, if you want to see it as a well-defined context-free grammar, a terminal symbol as a task, and we have the sequence block, we have the XOR block, and we considered the end block. A little difference with respect to other approaches that puts label on edges to discriminate which subset of activities have or have not to be executed. And here we associate to each XOR gateway a Boolean proposition which can be true or false, and that discriminates which branch of the XOR block has to be taken. After that, we consider label, and we labeled all the components of our process, the nodes of these workflow graphs. We labeled them by labels which are conjunctions of literals over these Boolean variables, and that in this way each label in each node resembles the nesting level in which that particular activities lies in the process. And basically with labels we are encoding workflow paths, so execution paths and even partial execution paths. This was the starting point for the model that we needed to carry out the complexity analysis. The extension we added was that of associating a set of resources to each task, but better say to each activity, to each node component of this fragment of BPMN. So you can see them as a set labeled before. Resources can be thought of as being users, the most simple, the most intuitive, but also machineries or autonomous systems or everything that needs to be committed for the execution of the task. In this work, we assume that at most, exactly one resource is committed for the execution of the task. So beside this, which is a simple consistency problem, we basically partitioned the set of resources and the set of Boolean variable into controllable and uncontrollable. Basically, we wanted to handle both controllable workflow paths, for example, this one, because this Boolean variable appears black, and uncontrollable workflow paths. So it means that once we execute these XOR gateways, it's not up to us to decide in which branch we will end up. And instead, if we have a controllable XOR gateway, let's say a XOR gateway associated to a controllable Boolean, it's up to us. We can decide which branch to go through. Likewise, we partitioned the resource assignment. So we commit resources for the execution of the task, and we partitioned them into controllable assignments and uncontrollable assignments. So if a node component appears with a red border, that resource assignment is out of control. So whenever we decide to execute a task, for example, T4, someone else, the environment, the nature, another player, if you want to see it as a two-player game, will assign this resource for the execution. In all these, we have a constraint, we have a set of constraints to satisfy, which basically says, which have the form of a pair label and a formula. A label basically is a workflow path. So we are saying that in this set of constraints, whenever the workflow path matches this part, some constraint must hold. Constraints are arbitrary Boolean formula over atoms of the form node equals to resource, where the resource is a resource associated to the node. Considering this model all together with these partitionings between resources and Booleans leads to a hierarchy of 8 classes of processes, depending on the considered and the not considered part. So we can have processes having only controllable resource assignment. Basically, we can have processes without XOR gateways, or we have processes with XOR gateways which allow for controllable and uncontrollable workflow paths, and we have processes with controllable and resource controllable assignments. And basically, in this hierarchy, you can see all the combination of these 4 parts. Every process always has a controllable node with a controllable resource assignment, because since we are considering well-defined structured processes, we always have a start point, an end point, and something in between. The first problem to define for this hierarchy is the easiest one, so the problem of consistency. So we are not here considering any uncontrollable part. So this we can also call this model, the model I introduced before has the name of business process with resources and uncertainty. Resources for the resource part, uncertainty for the 2 sources of uncertainty that I just introduced. If we forget for a moment of the uncertainty part, what is left is a business process with just resources and possibly, yes, XOR paths, but controllable ones. So the consistency of such a process asks us to find basically a workflow path. Here, being a complexity analysis, we are interested in finding one solution and not all the possible solutions. So this is really a satisfiability problem. Here we are interested in finding a workflow path and a resource assignment for all the nodes that are that belong to that workflow paths, so that all the relevant constraints for that workflow path hold. For example, in this example, we choose to go if we assume that both these XOR blocks are controllable. We can go for the positive for the true branch for both of them, and then assign the unique resource to T1 and then assign R2 to T3, because this constraint says that whenever the workflow path goes for the positive branch of the XOR block in which is associated to the Boolean variable A, this constraint must hold, so T3 must be equal to T4. And likewise, here we choose the positive branch of these XOR blocks, so that this constraint will hold, and this constraint becomes irrelevant because it has a precondition which is false. Moving to uncertainty, we have three main kinds of controllability. The easiest one is the weak controllability, in which we have a really strong assumption, so we can predict the future. So we assume that any possible combination of uncontrollable actions, which is an arbitrary big but finite set here, just because we don't really have time and intervals. Any combination of these uncontrollable actions is known in advance. And once we are told this combination, our job is that of complete that assignment, that workflow path. So choose which branch for each controllable XOR blocks and which resource assignments for the controllable nodes belonging to that complete workflow paths to assign in order to satisfy the constraint. In this example, suppose that we are told before starting that this XOR block will go through the false branch, and this uncontrollable resource assignment will assign R1 to T4. So we know that here we will have to assign R1 to T3 because this precondition will hold and this will not. And here the only way we have to satisfy either this constraint or this constraint, knowing that R1 is assigned to T4, is to choose this branch, because there is a separation of duty, if you want to call it with a more comprehensive name, in which requires that the resources that are assigned to these two activities are different. So here we know in advance all that. The other possibility, the other kind of controllability, which is a dual one, is a strong controllability. Strong controllability, we basically don't know anything about the uncontrollable behavior. So we look for some fixed assignment that involves all the controllable XOR paths and all the controllable resource assignment, such that in conjunction with what is going to happen will always work. This example is not strongly controllable, of course, because we have some dynamicity in here. For example, there is actually no way of predefining a resource assignment to this task, because this resource assignment will depend on which uncontrollable workflow path is taken here. And since we cannot do anything here, if we choose any of them, there will exist a scenario for which that assignment is not going to work. The last kind of controllability, which is the most interesting one, is dynamically controllability, in which can be seen as a two-player game, and whose goal is that of finding a strategy to always win this game. So this example is dynamically controllable. Dynamic controllability can be summarized as history-based controllability. So we observe what is going on, and depending on what we can observe, of course, we cannot observe at the beginning T4, because we have to get here to observe this uncontrollable behavior. But after we observe something, we make our next decision. For example, this process is dynamically controllable because regardless of the branch, of the uncontrollable branch which is taken here, once we get here, we know which one was it, and we can choose the right resource assignment. Likewise, once this uncontrollable resource assignment here is done and we get here, we know basically which branch we can choose for our execution in order to enable only one of these constraints and satisfy the constraint. And all this kind of controllability with strong and dynamically, of course, involve subclasses of processes that consider at least one source of uncertainty, not necessarily both. To prove the complexity results, basically, since the constraints are something that can be arbitrarily Boolean composed as a formula, we basically devise two procedures as a pre-step for the reductions, which convert any quantified Boolean formula in a fragment of this business process with resources and uncertainty. So basically, the two procedures differ one another because one does not consider XOR blocks and the other does consider XOR blocks. This is basically, if you take any quantified Boolean formula with an unbounded number of quantifiers, alternation, and a formula, you can see that each exists and for all can be either encoded into a task with controllable resource assignment if it is an exist, uncontrollable resource assignment if it is not an exist. This square box here as a label says that there is no label, so it means that it is always executed. Or if you want to encode this formula into a fragment of process which also have uncontrollable Booleans, so we are not considering controllable Booleans, so not considering controllable workflow paths. The reason will be clear in a minute. There is a way of also basically mirroring the uncontrollable choice of...
Sorry to interrupt, you should conclude the presentation.
Okay. And there is a way to mirror to the variables. So these in our complexity results basically say that consistency is a problem which is NP completed, and we reduct from a formula in 3 CNF, so from the classic 3 SAT. Weak controllability is a problem which lies in the second level of the polynomial hierarchy and is pi2 complete. A reduction is for all existing and a formula in 3 CNF. Strong controllability ranges from a special case which, if you have uncontrollable XOR blocks, it is NP complete. But if you also have a uncontrollable resource assignment, it is a sigma 2 complete. So another problem that lies in the second level of the polynomial hierarchy, and we can get there with a reduction from exist for all and a formula in 3 DNF. Of course, the uncontrollability is always space complete because we have an unbounded number of quantifiers, and we can reduct this a formula in 3 CNF. Membership is for all this problem is also is always straightforward, but you can point to the paper for the details. So in conclusions, we defined a formal model to work and explore complexity of resource controllability for acyclic business processes. And basically, we can consider consistency for processes without any sources of uncertainty, and controllability for processes with at least one source of uncertainty. And after that, we classified the complexity that is summarized in the previous table, but also in the paper. There is a longer discussion. The conclusion is that resource controllability of business process with resource and uncertainty, even if these processes are loopless, ranges from NP completeness to P-space completeness, depending on the class. Future work will devise for the we will look for strategy synthesis algorithm for the corresponding search problems and try to address loops in these classes of processes. Thanks.
Thanks, Matteo, for the presentation. Are there any questions from the audience?
Not have chat questions.
Okay, I have a question. I was wondering whether you tackle this problem only from the theoretical point of view, or you already have some examples of real processes that require strong or weak controllability.
No, I analyze this problem from a theoretical point of view because I come from constraint satisfaction or under uncertainty, temporal networks, and that kind of stuff. So it was more on formal models, but no, we don't have anything concrete at the moment.
Okay.
Francesco, I also have a question. Yes. Matteo,
Yeah.
how do you compare BPRUs to STNUs? Who is special case of whom? Because there's a big literature on STNU, on STNU, controllability checking, etc., and it's unclear to me currently who is special case of whom.
Okay, so this none is a special case of the other, because despite we here inherited the ideas of controllability coming from STNUs. STNUs is a framework for temporal planning. It is also this one, but from a qualitative point of view, because we have precedence constraints between activities and we have a qualitative temporal relation, which might be a special case of an STNU. However, STNU does not, the core model, I mean, does not have any kind of disjunctive constraint and does not have any kind of discrete variables. For having that, you need to consider more expressive and advanced results. So STNUs, as they are, they cannot really represent resource assignment here. And one other theoretical reason is that because dynamic controllability of STNU is in P, and here it's P-space complete. So no way that we can encode this formalism into the other.
Okay, if there are no other questions, I would thank again Matteo for his presentation. Thanks, Matteo, and I will move to the next paper. The presenter is Tathagata. Please, Tathagata, could you share your screen?
Yep.
The paper Tathagata will present is D3BA, a tool for optimizing business processing using non-deterministic planning. So Tathagata, the floor is yours. You have 15 minutes.
Thank you. You can hear me, right?
Yes.
All right. Hi, everyone. I'm Tathagata from IBM Research. This is joint work with Shubham, Yasaman, Yara, and Vache, all from the Cambridge lab in US. I'll be speaking about a tool that we are working on using non-deterministic planning for the optimization and composition of processes using planning. So we are looking at two specific use cases. One of composition of a workflow from these atomic elements. So this is what planning does in general, right? So it's not something that's particularly new, but it's something that's needed for the rest of the stuff. And then probably a more focus of the paper is on the optimization of workflows using atomic skills. So if you have a given process and you have a set of catalog of skills that you have access to, how you can match them together to get to more optimized workflows where the amount of automation is maximized. So that's the general overview of the work. In terms of contributions, again, we are looking at this use case of being able to merge an existing process with a set of skills to optimize it in favor of automation. And particularly in terms of the use of non-deterministic planning in it, you could, so traditionally planning has been always used for composing declarative elements, and non-determinism there has been used to model basically uncertainty in the world. So that's the usual paradigm. But one of the additions that we make here is the use of non-determinism as a design tool. So if you are able to use non-deterministic behavior at the time of modeling, you could let the designer of a business process be able to be in control of how the process will behave once you deploy it. So at offline, you can use the non-determinism as a design tool to make the process better before you actually go ahead and deploy it. So the way this works is, so basically you define individual components of an element, and then you get the scale up of being able to compose them into controllers. So the advantage of using is when you have repetitions in processes and a lot of sharing across different processes, and the complexity of the actual process with respect to these individual elements is higher. That's where you get to apply planning-based techniques. And again, these compositions always evolve with time, right? So you can add new rules, you can add changes to the existing rules, and you don't have to compose the process every time there is a change, right? You make a change in the rules, and then you let it reflect in the composed process. Let the planner deal with the process composition, and you can do the rules individually, declaratively. So, so as an example, here is a sample hiring process. The way this works is that you get a list of submissions, you go through the reviews, you do the interviews, and then you iterate on the final list of interviews, and it loops, right? So what we did is, as a proof of concept, we showed how this can be designed in terms of a declarative element. So you have here the set of actions, and these are not connected, so this is a set. And these are corresponding to the same, basically the action boxes here. And then once you provide the final goals of the process, you can compose that process using a planner. And so the controller that you have on the right here basically mimics the original process in BPM and to specification. If so, the point is that if you're doing it once, then there is no point in doing this for a single process, right? So you could have written, for a process of this complexity, you could have written just this one and not have to decompose it in its declarative forms. However, once you start changing the process, for example, you can add more goals, you can modify rules in it, then you can go to newer and newer processes based on the same elements. So, right, so here is a simpler version of the older one, which we got here by just changing a few rules. So you don't go into the exact, you don't modify the the compose process, you modify the declarative elements and let it plan apply. So what's going on under the hood is that every declarative element is defined in terms of a set of preconditions and effects, or needs and goals, or inputs and outputs, whichever you look at it. So on the left, you have, so what you're designing is capabilities of the system, right? So every capability requires a set of conditions to be true. So those are the inputs. So set of conditions can be logical rules, can be like values of variables you need to know. So any condition that needs to hold. And then you have a set of outputs as an outcome. And particularly for non-deterministic case, every outcome is exclusive from each other and houses a set of updates to the world state. Right? So if you consider, like, there are 3 outcomes here, each outcome would have a set of variable updates. And the non-deterministic paradigm works in the way that at planning time, you are using up all the possible contingencies or possibilities for reasoning, but at runtime, you determine which one of them actually happened. So the assumption is that planning time, everything can happen, and you are planning for for all of them. And then at runtime, one of them will happen. So you have to determine which one happened. And so what you get is what we call a contingent plan from a non-deterministic planner. So it looks like a tree. So these are all contingent plans. And as you can see, it is planning for different outcomes. So, and then once you actually execute it, it will have to figure out at runtime which one happened and then progress along that path. So that's sort of an overview of the underlying technique that we will use. Well, 2 caveats here, right? So composition is not magic. There is some level of knowledge that goes in here that you have to specify the declarative elements in terms of their inputs and outputs, but also those should at least share some vocabulary or can be mapped. So if somebody says, I produce B and somebody requires A, then if A and B are the same, there has to be a way to match them. And then it's only useful when you have a lot of reuse. So if you're designing one process, you could just design that process up front if it's small enough. But only when you get to these reuse situations, that's when you can use this sort of a declarative paradigm. So that's the basics of the system. And the use case that we were working on this is to how to actually take one of these existing processes and use sort of a catalog of skills to scale it up in terms of the automation possibilities in it. So for example, if you look at a travel application process, like somebody applies to go to a conference, then it goes to review, you have to provide a justification, estimated expense, and so on. If there are individual skills that can do that for you, so for example, take a look at the conference location and provide you an estimated expense, provide you the list of papers that you are presenting, then you don't have to fill in the justification and so on. So there would be those little bits of automation can shorten the process shorten the manual parts of the process for the caseworkers. So the idea is to look at the manual version of a process and look at automated skills that are available to the designer and be able to figure out where exactly we can inject automation there. So as an example of a catalog of skills, you can think of like the Automation Anywhere bot store, where there are like a bunch of individual skills that are not connected to each other. So you have a set of those skills available. You're thinking where exactly can we use them in the scope of an existing process. So what that would look like is that you have the original controller from the planner that we discussed previously, and then you have a skill that can bypass a particular part of a process. So here, there was a manual set of questions that the user had to go through, and there's a bypass of that using an automation. So you have these individual skills that will give you those optimizations. And then if they fail, you can always fall back. So that's part of using the non-deterministic way of doing things, is that you're modeling failure probabilities. And so so you optimize for the most optimistic outcome, and then you can fall back if things fail. And then going from one skill to many skills, what you will have is that you have one process and a set of these skills, and you can see where exactly those optimizations can happen and where exactly you can fall back. One of the points to highlight here is that this is not easy to do in the manual sense, because the optimization might be very, very complicated, especially if you're doing partial success of different stages of the process. So then the fallbacks are increasingly nested. And so it's very hard for a manual process to go through all those systems. So automation of the optimization process is very much a necessary part of it. And then every time you change the process, you don't want to update everything by hand. So you want to have that automation from the specification to the actual composition of the controller. And again, going back to the previous formulation for the skills as well, it's very much a similar form of specification. You have a set of inputs and a set of outputs. The only difference is that the compilation to the older specification is dependent on what you're trying to model. So if you're trying to model all the possible partial success of a skill, then you can model it as like a power set of all the outcomes. And then you get back to the older formulation of a non-deterministic outcome. I won't go into the details of using non-deterministic planning as a debugging tool, but one of the interesting things to highlight here is that one of the promises of being able to compose these skills and processes is that you're optimizing for the amount of automation. So you're minimizing the amount of human labor necessary. But as the amount of failure of skills increase, then you sort of see a counterintuitive result. So in this example, the black lines are the manual processes, the length of the manual process, and the black and blue added is the entire process. As you can see, if you increase the failure rate, the length of the process increases, which is sort of expected because there are many, many failures. And so the blue parts increase, but the black parts also increase, which means that the planner is trying to take paths that never materialize. And so the manual processes end up failing as well. And so you have many, many more fallbacks. So that's something that you can debug and make sure that you've got the balance right when you're trying to deploy something like this. So that's sort of a wrap. So the key takeaways is that of using non-determinism not only to handle uncertainty, but to model a process offline, optimize it using skills, and then iterate on the properties of that offline composition before deployment, so you know how it's going to behave when you actually deploy it. You can read more about the work here. The first one is about the exact specification used, so the theoretical details of it. And the second one uses some of the explainable AI techniques to explain a composition to the user. So if you're interested in using non-determinism as a debugging tool, you can take a look at that as well. And then we also have a related talk at RPA for session 2 RPA forum. So you're invited to come there as well. So thank you, and happy to take questions.
Thank you, Tathagata. You were perfectly in time. Do we have questions from the audience?
We have one from Andrea. Andrea, go ahead, please.
Okay, thanks for the presentation. I have a couple of questions in reality. So the first question is about the concept of optimization. When you say to optimize the process, what do you mean with optimization? Because there are several forms of optimization in processes.
I should have made that clear. So the specific kind of optimization we are looking at is how to minimize the number of manual steps and maximize the number of automated steps, basically. So if you have a process which is manual and you have a set of automated skills, basically the metric is to minimize the number of manual steps.
Okay, clear. I have a second question, if I can, guys.
Sure.
So you are using non-deterministic features to achieve your objectives. So my question is, because I have not get this by the talk. So why you need non-deterministic features, and can you use, for example, classical planning features to achieve your target?
So the specification that's being generated can be used both by a classical planner as well as a non-deterministic planner. It uses the same inputs, but the output is different. So the output of a classical planner will give you one sequence, which is the most optimistic sequence. Whereas the output of a non-deterministic planner will give you the contingent, like the graph, which has all possible outcomes. So in planning, once you go from the specification to the actual reasoning process, either you do all possible outcomes determinization or a most possible outcome determination. And there, the difference you get is in the design process of it, right? So if you're using a classical planner, you get a single plan, and then you don't know how it will behave once that fails. So you have to simulate that. And at best, you can get like statistics of, say, 1,000 simulations and say, this is how the planner will work. Whereas on the non-deterministic side, why we want to use non-deterministic in particular is because you get this tree visualization upfront. And so you know the different ways the agent will behave. You can visualize it, but you can also iterate on it, right? So you can ask questions like, so what if this path was not possible? What if I add a path here? Why is this one possible? Why is this one not possible? So once you have the contingent plan in view, you can use that as a debugging tool, which you don't get from the classical output. Does that make sense?
Clear. Thank you.
Thank you.
I have another question. Are there any other questions for the audience, Arik?
Not that I can see. I also have a question, but let's, you go ahead first.
Go.
So my question is this: are you actually trying to automate everything? So the goal is to ideally or ultimately put all your activities to the machine, or are you trying to also somehow preserve the human in the loop?
Well,
is there a consideration?
Yeah, so so an entire process is most likely not going to get automated because not everything is possible to automate. So most of the process will, or at least say a part of the process will remain manual. What the automation does is to give you alternative pathways, right? So if you say, so there are two ways where the manual process still remains there. One is in terms of, say, expertise. So the quality of, if you're worried that the automation give you lesser quality, and if you are putting in the quality as a metric, then it will choose the manual one unless there is a reason to choose the optimal one. So for example, the manual caseworker is already taken, so you have to fall back. So whether the fallback happens first to the manual or first to the automatic one depends on what your metrics are. And secondly, once the automation fails, you have to fall back anyway. So everything is in terms of, and that's one of the reasons of, that's like the classical reason of using non-determinism is you can model failures upfront. And so you have a bunch of skills that you can use, but they may fail and they may have quality issues. There might be costs associated with that, right? So if you are somebody who's trying to design a new agent and you have a catalog of skills and the skills cost money, then so that will also determine what fallbacks are available or not, depending on your budget. So there's a lot of considerations that goes into determining whether you have the automation there or not. And then some, of course, many of the tasks are not possible to automate once they're of sufficient quality. So you want to automate away the repeating, like the menial ones, and give the better ones to the human caseworkers.
Thank you. Francesco, we have a question from Ingo. I don't know if we have time.
Yes, I think we have.
Ingo, go ahead, please.
Sure. If you're short on time, maybe I can make it a comment. I actually wrote my PhD thesis on, subject matters related to that, closely related. One of the core chapters of the work was using composition in the context of business processes. So I'll just copy the information, the name of my thesis in there. And then you can
say that a lot of the motivation comes from like web service composition. Like there's a lot of work out there. It's in particular on composing web services for business process using planning. And so the composition part is definitely not something new that we are proposing. It's more on the design side, like what you can do with the offline sense, and not just like the composition part. But yeah, there's a lot of work that we have built it on. That's already out there. We're happy to take a look as well. Send me the link, definitely.
Yeah, it's in the chat. Thanks.
Okay, thank you.
So thanks again, Tathagata. Now we move to our next presenter, who is Aleš.
Yes, hello.
Aleš, are you there?
Yes.
Can you share your screen?
Of course.
Aleš will present us his work on conceptualizing a capability-based view of artificial intelligence adoption in the BPM context. Please, Aleš, the floor is yours for 15 minutes.
Welcome, everyone. This is conceptualizing a capability-based view of artificial intelligence adoption in BPM context. I'm Aleš Zivec, and this will be a more management and business-oriented presentation. So the question was, what can AI do for business? AI is a 21st century general purpose technology, and it has some typical GPT characteristics like pervasiveness, improvement, continuous improvement, and potential to spark innovation, and is slowly creeping in every aspect of society. So our research is concerned with AI business value generation. And AI is a very broad subject, as you all know. And we wanted to use a broad enough definition of AI to capture all the ways AIs can be used in organizations. So we came up with the definition. Here is this definition: a simulation of cognitive functions using intelligent agents. Agents are capable of receiving precepts from environment and performing actions. So performing cognitive functions with the machines opens up a lot of opportunities in business. And we mostly talk already in the keynote was this was stated really clearly, was automation and augmentation capabilities of AI. So the question is, does bringing AI into organization or workplace increase productivity, and does it help make people better and faster decisions? So although the infrastructure, data, technology frameworks, AI services are readily available, organizations have quite a lot of difficulties leveraging AI technology, managing it and realizing performance gains. Only 5% of organizations have extensively incorporated AI, and 20% have partially used it. So we looked at the different use cases, and there are no real out-of-the-box solutions. AI is always about data and domain knowledge. But it has some great value propositions. We identified speed, scale, granularity, learning, accuracy, and AI assistant decision making. So we opted to study AI impact in the context of BPM because we like business processes and the structure behind it and how you can manage them. And we contextualized the integrative IT business value model from Melville that states that IT resources will impact business processes and business process performance, and this will result in some kind of organizational performance. And with our research, we argue AI adoption will impact process level organizational capabilities like cognitive business process automation, business process innovation, organizational learning. It will have an impact on decision-making performance, and this will result in a significant improvement of process performance. Improvement in process performance means higher productivity, competitive advantage, better market positions. And to study this impact, we first have to define the concept of adoption of artificial intelligence, then operationalize it to be able to measure the extent of AI adoption in organizations. So the next step was literature identification to find out if there is already an existing construct covering this. We found only 2 studies related to AI adoption listed here, but we found no construct assessing AI adoption extent as exogenous component-based variable related to the extent of implementation or utilization of specific AI technologies, applications, tools. So we decided to develop a new concept, and we followed the well-known Podsakov recommendations on concept definitions. These are 3 steps we followed. They are collecting possible attributes. We separately examined the concepts of adoption and artificial intelligence, and the procedure included examining the definitions from dictionaries, antonyms of both concepts, literature review, and we supplemented the findings with in-depth semi-structured interviews. Next, we organized these key potential attributes in common teams. We identify first order categories, second order teams, and then aggregated them in dimensions that comprise the focal construct of AI adoption. So here we have some example definitions of adoption. There are different theories and frameworks, and we extracted attributes from them, but the definition we used is mostly adapted from technology innovation adoption. And adoption is a process that is concerned with decision to adopt, and then with the implementation and usage part. And we are more interested in implementation and usage part, so we can manage the extent of the adoption of technology in companies. The next step was to extract definitions for artificial intelligence. So there are a lot of definitions. They're very broad or very specific. So we extracted some useful attributes for them, and we defined the AI as a simulation of cognitive functions using intelligent agents. A lot of people at this conference and in this workshop use the term intelligent agent. We adopted the definition of intelligent agent or AI system that was developed by the group of experts at OECD. The reason was it has the most broad consensus and is based on conceptual definition by Russell and Norvig. And as you can see here, if you have time to read it, it's a very broad definition, and it can easily encompass all the ways AI is used in organizations or if different types of AI tools, technologies, applications, and so on. So next we extracted attributes from AI types. We looked at narrow intelligence, general intelligence, super intelligence, all very known terms. Next, we analyzed and extracted attributes from definitions of specific AI technologies listed here. So there are quite a lot. And then we looked at AI capabilities. We identified capabilities of learning, sense, act, and comprehend. These are typical capabilities that always pop up when reading articles on AI. And of course, we looked at AI application domains. Their most prominent are robotics and automation, then analytics, human-computer interaction, and decision support. At the end, we supplemented this with 9 in-depth semi-structured interviews. We had interviews from managers, academics, experts, from financial services, so banks, insurance, government organizations, AI technology providers and solution providers, manufacturing and energy sector. We were talking very broadly about AI adoption, their experiences, about AI implementation, deployment, and actual use, and what value they were able to extract. Here is an example of findings from these interviews. Mostly AI project originated in analytics departments, focusing on prediction and classification or decision support and human-computer interaction, specifically chatbots and recommendation systems. So this was the extraction of attributes. We organized them in these 5 subdimensions that define the adoption of artificial intelligence, and I think they're mostly covered all the ways AI is present today in organizations. Next, we defined the focal construct of AI adoption, and we define it as the implementation of AI resources in business processes. In the AI resources, we define them as these attributes: scalable infrastructure, AI assets, data, trained models. Trained models are perceived very differently. Some see a lot of value in them, some less. Then AI skills, domain knowledge, expertise, capabilities, partnerships, AI talents, and so on. We define the property of this construct as the ability to develop a set of distinct AI-enabled capabilities through the implementation of AI application tools and technology. And the property of this construct applies to the entity of an organization. So the idea is to measure the extent of the adoption at the organizational level. If we move through the sub-dimensions, the first one is data acquisition and pre-processing. We define the ability, this ability as the ability to extract data from structured and unstructured sources. So the 3 basic routines that pop up here are data extraction, data pre-processing, and the continuous assurance of data quality. Their purpose is to deal mainly with big data, so increasing volume, variety, and velocity of data, collected from internal and external sources, data sources. So the amount of data today is enormous, and here are some data management applications and tools used in organizations like data warehousing, data capturing systems, and so on. So the next AI-enabled capability we identified is cognitive insight, the ability to use AI to detect patterns and data in data and interpret the meaning. This dimension is conceptualized around themes of context awareness, learning, and analytics mainly. So here are the usual applications: predictive sales, churn management, fraud detection, risk management, and so on. There are quite a lot of applications from this area. And the next one is cognitive engagement. We define this capability as the ability to support AI-enhanced human-computer interaction. The key elements here are understanding. Commonly, natural language processing is used, or text analysis, and so on. Then very important is the perception of intention and coupling with domain knowledge. So here these applications and tools have the ability to enable automated interactions with customers or internal users and prompt their engagements. So everyone probably already used some of these applications like chatbots or recommendation systems in their daily lives. So next one is cognitive decision assistance, the ability to use AI in decision-making processes. This renders the decision support more intelligent, speeds up information flows, provides predictive, adaptive decision support, and solves knowledge intensive problems. These technologies and approaches are usually implemented in decision support systems, AI-enabled decision support systems, expert systems, fuzzy logic systems, and so on. So the last sub-dimension that comprises the concept is the ability to integrate AI technologies with other IT resources, services, and devices. This dimension was isolated by the conceptualization process for cases where organizations do not deploy and use AI in a specific application or tool, but use specific AI technologies and integrate them in their existing IT resources and business processes. And the idea behind this is they're not, these AI technologies are not merely used, but utilized. And this implies they're used in innovative ways, creative ways beyond the intended use. And the usual suspects here are machine learning, deep learning, natural language processing, genetic programming, and so on. So these are the 5 sub-dimensions that comprise the proposed construct of AI adoption. And the last part of the conceptualization process was the refinement of the definition, and we were talking with a lot of colleagues, academics, experts, managers, to fine-tune the definition. And the next step is, of course, the operationalization of proposed dimensions to be able to assess the total extent of AI adoption in organizations. There is planned an EU-wide comprehensive study among EU companies. So we get some empirical evidence of this AI business value generation process, and a more detailed view of how this is accomplished with AI technology. So this was the capability-based view of adoption, and thank you for listening.
Thanks, Alish, for the nice presentation. Do we have questions from the audience?
We do not.
Okay, I have a question. I know this is not properly a systematic literature review, but I would like to know from you which is, in your opinion, the dimension among the ones that you mentioned, where the BPM community focused more.
I think the BPM community is mostly focused on insights, cognitive insights, and AI-assisted decision making. These are the two. Also, the first one, the cognitive insights or the analytics, is where I see process mining and so on. And the most interesting one and the difficult one is the AI assistant decision making, because there is a lot of promise that AI automates a lot of things, but in reality there is always someone at the end who gives the okay before the decisions made by AI systems are utilized. There is not yet the level where people will trust AI to do all the work. So yes, I think this is the most interesting two capabilities or dimensions for BPM community.
We have a question by Dirk. Dirk, please go ahead.
Hi, Alice. Thank you very much for the nice presentation. While you were talking, one thought crossed my mind. Whenever I'm on social media, the platform always gives me recommendations of stuff I should consume, but I actually don't want to consume. I'm really not interested in it. You can tell the platform, I don't want that, downvote this. But the platform never learns, right? It kind of refuses to take in my preferences.
Yeah.
Now, if we're talking about intelligent agents to support workers in a business process, then that easily can come in as well, right? The agent may not have all the context factors, all the context knowledge available to know that the advice it's giving at that moment is not a smart one. As a person, I know a bit better what I need. Mm. Is there anything there in the literature that deals with stopping stubborn AI agents from giving me advice I don't want? So is there anything in that relation? Because it's like a person, right? That if I have a person in my room or in my cubicle, I can send them away. You know what? That advice is not working. And they leave me alone. But an AI agent, it sits inside my computer system. I can't send it away. It's always there. So is there anything on that in the literature that's discussing this at least?
Yes, there are some articles talking about this stuff, but the reality behind this is, like you were mentioning, if we separate the customers and the internal users in organizations. So when we are talking about customers, like you said, like on a platform recommendation system, it's so the opt-out option for not getting the recommendations or whatever. This is by design. Businesses don't want to shut down these recommendation systems because sometimes they know better than you do what you need. And this is no, really, because if you look at it, I have a lot of experience. I done some work on such a system, because you feel someday you feel it's too much, I don't want that, but the next day if you opt out, they will not show you any recommendations. The next day, maybe you would like these recommendations. And they track your clicks, what you're looking at, and they calculate the probability you will be interested in that. So this retargeting and this stuff around this marketing technologies is always, it's the business opportunity and the business idea behind it. It's by design. For internal users, you have some things where people were did moderation on these recommendations and so on. So you had moderators, and they had parallel systems and so on. And yes, there was always the issue to trust AI and the recommendations of AI, or trust a person. And the people are more leaning on the side of the trust the person. But this is also a cultural thing. This is one thing I didn't mention here. I will also include in my research organizational culture and some specifics about the culture in general, because in Asia they're more leaned to trust AI and these automated systems opposing to the EU, for example. So there is a lot of area not well researched. One colleague of mine at our faculty is currently researching how people react to chatbots, because there is a lot of promise how these chatbots will affect business, but in reality, okay, let's forget Siri and Alexa and so on. These chatbots that other firms are buying or you have on Microsoft or Amazon platforms and so on, they're not so effective.
Yeah.
People always, when they have a problem, want to talk to a person.
Yeah. Yeah.
And there is a lot of research to be done here, yes.
Thank you.
Yeah, you're welcome.
Okay, thanks everybody. I thank all the people who attended this session, also on behalf of the presenters. Now we have a break until 15:15, I think. And so see you for the next sub-session. So thanks everybody.
Thank you.
So hello everybody. Welcome to this last session, exciting session of this exciting workshop on process mining using AI. My name is Avigal, and together with me as the co-chair, Arik Santurovic. In this session, we're going to have 3 papers. You know the rules. All in all, 20 minutes. So this is like 15 minutes lecture and 5 minutes for questions. And without further ado, we just, oh, we reached 100. Yay. Okay, so the first paper, Yunam, do you want to share your screen?
Yeah.
A general framework for action-oriented process mining by Yunam Park and Will van der Haus. Floor is yours.
Yeah, thanks for your kind introduction. My name is Kyunam Park from the chair of Process and Data Science, headed by Professor Will van der Haus, who is also one of the co-author of this work. Today, I'm going to present a general framework for action-oriented process mining. So, sorry. These are the contents. So after a brief introduction, I'm going to explain the general idea behind the framework, and then later architecture and implementation of the framework. Afterward, I will explain the proof of the concept to evaluate the feasibility of the framework, and then I will conclude the presentation with the related works. So process mining has provided many techniques to gain insights of the real-world process by analyzing events from information system. The discovery, conformance, and enhancement techniques have provided many in-depth process-related knowledge to process managers or process analysts. So the process analysts have been very good at using those knowledge and insights to make one-time report. However, the true value of process mining could be achieved with the continuous process management. So from the diagnostics to the actual process management actions in a repetitive and continuous manner. However, this type of one-time report doesn't really enable this type of continuous process management, making the business owners have the impression that process mining projects are longer term and require fundamental changes in the process that they cannot do. Yeah, to compensate this limitation, there has been active research on online operational support that aims at analyzing the running instances in the process intended for controlling the problematic instances in the process. So thanks to the recent breakthroughs in the artificial intelligence, there has been extensive developments of predictive business process monitoring techniques that provides time-related values or risk probability or next event related values. But still having this type of timely information doesn't enable the actual process improvement from the continuous process management. That's because the action part is still missing somewhere between the diagnostics and then the management. So in this work, we propose a general framework for action-oriented process mining to fill the gap between the diagnostics and then the actual management actions. So this framework supports the continuous monitoring of the operational processes and at the same time enable the automated execution of actions. So this is the overview of the framework. So these are two major components of the framework. First, a constraint monitor, and second, action engine. So first, constraint monitor translates the event stream, which is the infinite flow of event records, to the constraint instance stream, which is the infinite flow of constraint instances that describe the monitoring results. And later, action engine transformed this constraint instance stream into action instance stream. That is the infinite flow of action instances describing the actual actions that can be executed to the information system to improve the process. So I'm going to present the general idea behind the constraint monitor and action and one by one. So first, constraint monitor evaluates the constraints that are defined with different sources of diagnostics. For example, from the process model, we can identify the problems in the control flow and then can detect some deviations in the process. So let's suppose this is the part of the process we have in our order handling process. And as you can see here, we identify that there is redundant repetition of check availability activity. So to monitor this type of violation or deviation, we can design or formulate a constraint that says check availability should not be repeated in the same date. And now the constraint monitor, based on the constraint, analyze the event stream and generate the constraint instances. For example, in the context where item 8 was handled by John, there was a violation, etc. And next, action engine assess the necessity of actions by analyzing the constraint instances and generate the actions that can be directly applied into information system. So there could be many different types of actions, but in this work, we mainly focus on 3 different types of actions. First one is process level action that aims at making changes in the major component of the process. For example, we can change the control flow of the process by making some activities into parallel relation, or we can adjust maximum capacity of the process, or we can change the routing rule in the process. Second, instance level action is mostly focusing on the single cases in the process. For example, we can abort some risky cases in the process, or we can assign some special resources for, to take care of some important cases in the process. Last, the alerts are about facilitating the employees in the organization to make some changes in indirect way to improve the process. So based on the constraint instances that are generated from the previous step, action engine evaluates this simple condition to see if there is a necessity for the action or not. So let's say we can impose an action like we need to change this activity into batch processing or some other, we can also apply some other properties to the activity. So next, I will going to explain the architecture of the framework by focusing on more important aspects. So first, event stream is an infinite set of events, but here in this work, we use a more realistic event notion where multiple case notions can coexist. For example, in the first row of this table, we can say that this event is about placing order, but there are multiple objects involved in this event. We cannot simply assign some arbitrarily single notion, case notion here. For example, if we assume that item is the case notion for this event, we are going to have two different place order activities, and then it just impairs the correct or precise analysis. So for more information about this more realistic event data concept, please have a look into this recent work titled Object-Centric Process Mining, dealing with divergence and convergence in event data. So next, constraint monitor is a function that maps event stream into constraint instance stream, being parameterized with a set of constraints where each constraint is a tuple of constraint formula that specifies what to monitor, and then a set of time moments that specify when to monitor the constraints. And next, action engine is another function that maps constraint instance stream into action instance stream, where the action is composed of an action formula and then a set of time moments. So here the action formula specifies how to assess the constraint instances to generate the corresponding actions. So based on the architecture, we implemented a prompt plugin called AOP.
You have 5 more minutes.
Yeah, thank you. AOPM plugin, it basically requires 3 different inputs, including events and then constraint formula definition and action formula definition, and it outputs action instance stream. So for more information about the formats and languages, we developed a plugin manual, at the link below. Please have a look into the link to use the tool for your experiences. So these are the screenshots. Yeah, I'm gonna skip those. So based on the implementation, we conducted several experiments to answer the following research questions. First, does the constraint monitor effectively detect violations? Second, does the action engine effectively generate corresponding transactions? Finally, does the application of transactions improve the process? So for the experiments, we designed a synthetic information system that consists of the data model on the left-hand side and then the process model on the right-hand side. So in the process model, you can see that it starts with the place order activity and it ends with delivery completion. So this is the procedure for the experiment. The information system continuously generates events, and then the constraint monitor continuously evaluates the constraint formula that formulates an order must be delivered in 72 hours. And then action engine assesses the action formulas. So here 2 action formulas. The first one is for any violation, we set higher priority. And if the violation is longer, we send a notification to the case manager. And then finally, a dedicated gateway defined for the information system translate the actions into real transactions that are executed in the information system. So this is the result. The figure on the left-hand side shows the answers for the research question 1 and 2. So here the order, the gray box shows the life cycle of the order, and then green arrow shows the requirement or constraint we have at the moment. So for any order that exceeds this green arrow, there are violations detected, and then also actions executed to reduce the risks from the violations. And then the figure on the right-hand side shows that after applying some transactions, the process has been improved. So I'm going to introduce related works of our work. First, to implement constraint formula, we can employ or deploy some process mining techniques like conformance checking, deviation detection techniques, or predictive business process monitoring techniques to make it more proactive. So there has been several action-oriented research, including Celonis action engine and also other proactive action generating techniques. Celonis action engine, however, doesn't support process processing streaming data, and then analyzing signals, and then executing actions at process levels that are all supported in our proposed framework. And then there has been some other techniques like optimizing resource allocation and making prescriptive alarms, but they are mostly focusing on specific problems with instance level actions. So as a summary, we propose a framework for the continuous process management and actual process improvement. And then we provided the formal definitions of the architecture and concrete implementation of the framework. And then we evaluated the feasibility on a synthetic information system. And about future works, it's quite straightforward. First, we need to develop efficient method for constraint monitor and action engines. And also we need to evaluate our proposed framework on real-life processes that are supported by SAP or Salesforce information systems. At the same time, we are planning to develop taxonomy of constraint and actions to give the guidelines to the business managers that to use this framework in a more efficient way. Thanks for your attention. This is my presentation, and feel free to ask any questions. Thank you.
Yeah. Thank you, Vinam. Sharply on time. That's excellent.
Thank you.
I don't see questions in chat. You're all welcome to write questions in chat and ask them now if you have a question. So I have a question, Gina.
Yeah.
So this tool is good for both streaming scenario where you're trying to constantly monitor the process and kind of a, let's say, weekly report, dashboard style of process monitoring, or is it only the time scale of streams and streaming events?
Yeah, so our framework is composed of two major components. The first one was a constraint monitor, and then the second one was action engine. So the constraint monitor part could be also employed for making some dashboard functionality or whatever. But our focus is more on connecting the constraint monitoring results into the real actions. So the answer could be yes and no. Yeah.
All right, thank you. We have 3 questions. So Stefan, go ahead, you're first.
Hi, thank you very much for your presentation. As far as what I was getting is that you're only considering behavior that already appeared, right? So there's no, you didn't insert any predictive process monitoring system yet, right?
Yeah.
Are there any plans to change that? And if so, then the difference to the existing predictive process monitoring system comes, for me, not clear anymore. So yeah, can you elaborate on that?
Yeah, so here in the definition of constraint monitor, I explained that it's parameterized with a set of constraints. And the constraint is also defined with a constraint formula and then a set of time moments. And this constraint formula could be anything. Okay. So it could include a predictive property inside. And then, yeah, this becomes predictive or prescriptive technique. But if it's not the case, it would be just, it's still reactive technique for improving the process. So the answer is, it's possible based on the architecture we have. And yeah, actually our future plan also includes to incorporate some techniques from predictive business process monitoring techniques to implement this constraint formula. Thanks for your question.
Thank you very much.
We have the next question coming from Dirk.
Yeah, thank you, Arik. Thank you for the nice talk. I have one question related to comparing your work to, say, classical BPM engines. I mean, it's clear you step outside a classical single instance situation, right? So you're much broader. I want to look one technical step closer. What BPM engines give you are transactional guarantees about certain pieces of work that are being done, right? When you have a workflow model, a BPMN model, you design the task in a way to be sure that data is kept consistent according to the process logic. And if you do this completely in a data-driven way, you may run the risk that the data that you're updating is not in line with the transactional requirements that you have on the data, especially if once you step out into a real data-driven world where you basically operate directly on the database. So in what ways can your constraint-based approach, discovery approach, capture this kind of transactional expectations by the data, this consistency expectation by the data, or is this just outside the scope of your approach?
Yeah, thanks for your question, Dirk. It's indeed very good point. At the moment, this has not been our scope, but of course, this should also be considered. But what we are considering at the moment is we can have the feedback mechanism in our framework so that we can ensure that the transactional data or the database itself is already been insured or secured, and then the following actions are effective to solve the problem. I mean, here in terms of the effectiveness, I mean, there should be relevant actions based on the clean data set. So by having some feedback mechanisms inside, I think it would somehow tackle the problem. But yeah, of course, we need to also think about it, and really thanks and really appreciate your good insights for the transactional part. Yeah, thanks for that.
Yeah, thanks for the feedback. Tricky problem. Thank you.
Yeah, it's not easy. Yeah, but thanks for that.
So I suggest we'll take one last question. There is one more on the chat, so Ginam, you can answer it there. Actually, Ahmed asked a question that I wanted to ask myself. There is a whole world of complex event processing and complex event engines. So exactly what is the difference? And if you considered using such engines to solve your problem?
Yeah, thanks for the question. What we are planning is to deploy those techniques, including complex event processing or other detection algorithms. And yeah, as I explained with the constant formula, it could be anything. It could be predictive, it could be reactive, it could be, that's about the, that's about the output part. And also for the implementation, we can incorporate other aspects like complex event processing or conformance checking, for example. Yeah.
Okay, thank you. So again, there is one more question on the chat. We will move on now. Monica, can you release the share screen?
Yeah.
Thanks. And Monica, can you post yours? So the next paper is analyzing comments in ticket resolution to capture underlying process interactions.
Yeah. Hello. So can you hear me? Yeah, okay. So I'll be presenting the work which is titled as Analyzing Comments in Ticket Resolution to Capture Underlying Process Interactions. This work is jointly done with Prerna, Tarun and Sampath from IBM Research and Dr. Alexander from Eindhoven University. I'll be presenting this work. Okay, so the motivation behind this work is that, like Park just described, that, with process mining, we have essentially the event log as the input, and we try to discover the process model. And most of these techniques actually make use of the structured logs and basically focus on these three, four main attributes: the case ID, the activity name, and the timestamp. But in many cases, actually, a lot of unstructured text is also generated during the process execution. For example, that, the person who is involved during the execution might write some comments that I'm doing this particular activity, which is generated along with those structured logs. So the idea here is to make use of those comments to enrich the discovered process model and have better insights for efficient process improvement decisions. So just to give you an idea for the usefulness of these comments, I'll start with an example. So, like, in during any ticket resolution process, the agent can ask for some clarification questions from the user, and this asking question activity typically gets logged as need information from the client. And correspondingly, the agent would write something like that, in order to assist you more effectively, we ask that you please provide the following information: that which OS are you using, and which web browser are you using. So the idea is, had we discovered the process model just by using the structured logs, what we would see is this single node, that, need info client as one of the activities in the complete process model. But since we decided to also make use of the comments, we were able to see a more granular view of what is exactly happening when the agent says need info. So for example, uh, from a set of comments which is accompanying this activity, we were able to find out that, these are the kind of things being asked. Now, what is the value of having, this complex subgraph as a replacement for the single node? So now that, we have a detailed view, we can make a decision like that, the operating system and web browser are asked quite often. So therefore, we may decide to have a bot which can automatically detect these two information when the ticket is submitted, because it is very much possible to, get these two things automatically. So it helped us make this level of decision, which was not possible otherwise if we just had need info client. So now that we see the value of leveraging comments and having an integrated view of the process model, we decided to discover the detailed process model for the ticket resolution process by making use of the information which is present in the comments. Now, by discovering such a model, the idea is to be able to identify the inefficiencies more precisely. So to achieve that, here is the approach that we propose. It mainly has three stages. The first stage basically includes that, we have an event log which has case ID, the timestamp, the activity, which would be something like need info, and if there is any corresponding comment associated with it. Now we need to choose that which specific activity do we want to investigate in detail. And the reason behind selecting this is that, if let's say there are comments for many activities, and if we try to get this kind of subgraph for all of them at the same time, it is possible that the complete graph may look like a spaghetti. So the idea is, you can upfront choose that I want to just focus on this particular activity, let's say in this case need info client, so that we analyze the comments corresponding to only that specific activity and get an enriched process model. Once we have selected the activity which we want to analyze in detail, we perform the unsupervised key phrase extraction from the corresponding comments. This unsupervised key phrase extraction module has 4 steps within it, which I will explain in detail in the follow-up slides. Once we have extracted the key phrases, we derive the enriched event log, using which we discover the enriched process model. So let me start with the unsupervised key phrase extraction. But so the thing is, if you see, right, it has mainly two things to it. One is unsupervised, the other is key phrase extraction. There are two ways to extract the key phrases. One is supervised and the other is unsupervised. And like we know, with supervised, one of the main challenges is that we need annotated data, which is not possible always. So we decided to go for unsupervised approach. And key phrase extraction is about automatic selection of important phrases from the complete text. Now first thing we do is we pre-process the comments. As part of pre-processing, we do things like stemming, case folding. We remove some HTML tags if they are present in the text. We remove stop words if there are any special characters. And another thing we do is that many a times, if we are looking at a specific process, we might notice that there is a lot of repetition of sentences across different comments. So to optimize that performance of the algorithm, we decided to actually get a unique set of sentences when we try to extract the key phrases. Once we have pre-processed the data, we try to generate the candidate key phrases. This approach is inspired from the core phrase algorithm, which is published as a paper in as a paper titled "Core Phrase Key Phrase Extraction for Document Clustering." And one of the main idea here is to leverage document index graph because it allows us to perform the computations in near linear time. And what exactly this DIG represents is it's a cumulative graph for the entire set of unique sentences we have. And once we have this cumulative graph, we take every sentence one by one and try to compare that sentence against a subgraph, which is the global graph, but except the graph for that sentence. So now if we try to do an intersection between the subgraph, the global subgraph, and a graph for this particular sentence, we try to find out, okay, these are the common key phrases between this particular sentence and the remaining subgraph. So it is essentially a graph-based approach. Once we have a set of candidate key phrases, we try to rank them to find out which ones are more important and which ones are less important. To achieve that, we make use of TF-IDF based approach. But here, unlike TF-IDF, we give more importance to the phrases which are present across more comments. So the score is computed as a product of phrase frequency and log inverse of comment frequency. Phrase frequency is basically the number of times the phrase has appeared in one comment normalized by the length of the comment, and the comment frequency is the number of comments in which P appears, the phrase appears normalized by the total number of comments. So using that score, sure, okay, thanks. Using this score, we try to rank the key phrases. Once we have the set of ranked key phrases, we further process those set of key phrases. So the idea here is that sometimes there are some things which are domain specific and they might appear as higher in the rank. For example, in our case, there was something as contact help desk. It was not removed as part of pre-processing stop words because we wanted to keep the stop words list as generic. But here we notice that, you know, this is something which they write in a lot of comments. So it appeared as a important candidate key phrase, but it doesn't really add any significance. So those kind of key phrases were then removed. Now we have already looked at this unsupervised key phrase extraction, which involved 4 steps. Once we have the set of final key phrases, we actually annotate our comments using those set of key phrases, which I'll explain here. So for example, if you see here, right, in the structured event log, there is an activity which says need info and there is a corresponding comment written here, which says for further assistance, please send us the session ID, web browser, operating system which you are using. Now using this comment, we compare it against the extracted key phrases and we find out that out of all the extracted key phrases, it has 3 or 4 of them present here. Now let's say 3 of them are applicable. then what we do is we retain the same timestamp, because essentially these things are then asked in parallel, and we create 3 entries corresponding to the single event from the structured logs. So now this is how we actually create the enriched event logs. Using this enriched event log, we discover the process model like the one I showed just in the beginning. Now, in order to evaluate our key phrase extraction, we make use of example-based evaluation metrics. Why example-based metrics? Because here the correlation between different classes might have significance. So we used these metrics, which is accuracy, precision, recall, F1, and Hamming loss. For this proposed approach, we perform a case study on the dataset of a large global IT company, which has tickets for around 2,600 IT support tickets, which has data for these many events. And out of all the activities, we decided to focus on these 2, change value and need info. So these are the ones where the analysts were writing some comments. Using those, we decided to evaluate the performance, and to evaluate the performance, we had to manually annotate the ground truth, which included mainly 2 things. First, we identified the set of key phrases, and using that set of key phrases, we manually annotated the data set. And there was inter-annotator agreement, which was checked to make sure that the annotation is done correctly. Now, we compared the performance of proposed approach against the ground truth that was annotated manually. As you can see, for almost all the comments, roughly 4 labels were assigned. So the L is basically the number of average labels for each comment. And we extracted roughly 33 key phrases for change value category and 16 for need info, which means if you just blow the graph, need info will be split into 16 and this will be split into 33. And the approach performed quite well with a fair accuracy of roughly 80%. And the F1 score is also in the range of 80%, which means there is a good trade-off balance between the precision and the recall. So I would like to just conclude by saying that, we create a multi-step approach to integrate the hidden knowledge which is present in the unstructured text. Here in this particular case, we used comments, and the accuracy of our approach is roughly 80%. And this helped us in making efficient improvement decisions. And one of the things I would like to mention here is that, as you can notice, right, we did not really make use of the semantics. So as part of the future work, we want to try out more advanced techniques and make use of the semantics. Yeah, that's all. Thanks. If there are any questions, please feel free to ask.
Thank you, Monica. While you were speaking, I think Wova kind of crashed on you. So people were rushing to see your screen on other means. I hope that didn't interrupt too much. Yeah, we're waiting for questions. Either on
we currently don't have questions in the chat.
Okay, can I ask one then? Monica, it was very interesting. I was wondering, did you, maybe you showed it and I missed it. What is to what extent did the comments actually added to your ability to accurately discover the process?
Right. So like I showed through an example that, we could actually find that what exactly was being asked by the analyst. So for example, we could find that operating system is asked more often. So this clearly helps us to decide, okay, there is a need to create a bot to optimize this part and therefore decrease the total number of such user needs basically. And similarly for change value, we noticed that, a lot of times the severity of the tickets got changed, which means that we need to have a more optimal way of finding out the severity. So which was not possible otherwise.
Okay. Do you have any kind of benchmark that you can use, that people can maybe try different techniques to see whether they will be, these comments will be more useful or less useful than, for example, as a baseline, not using any of the comments?
No. So actually the data we had used was our industry data. So we have not made that data publicly available. So I don't think the comparison is possible.
Okay. Any other questions?
We have a question here from Faria. Faria, you want to ask?
Yeah, thank you, Arik. Thank you, Monica, for your presentation. I just had a question about the steps kind of in your pre-processing after you cleaned up your keywords. So, so you got rid of the stop words, you did some stemming, and then did you apply the core phrase extraction algorithm on those cleaned words, or maybe I missed something in the middle?
So we applied on the set of cleaned version which we created after pre-processing.
So that like you cleaned the words and then you applied the algorithm. You didn't do anything like n-grams or anything like that.
So so basically we do these pre-processing steps, stemming and all of that, and then each token, each word is represented as a single node in the graph.
Ah, okay.
Yeah.
Okay, thank you.
We have another question by Ahmed. Ahmed, you want to add? You want to ask? There's a question by Ahmed asking, how do you manage the list of duplicate key phrases?
Okay, so basically when we try to extract the key phrases by doing intersection between the subgraph of a single sentence versus the global graph, what we do is if something comes out as a key phrase which is already registered in the list of key phrases, we just increase the counter. And that's how we maintain the counter, which is then used for calculating the score.
Thank you.
Yeah.
Okay, great.
Thanks.
So thank you, Monica. We're moving to the third talk. Amy, do you want to upload it? And this paper is on automated business process discovery from unstructured natural language documents.
Hello.
Great.
I think we should be up now.
Yeah.
So good morning, afternoon and evening to everyone, wherever you are in the world. So I'm Amy Stringfo, a researcher at Defence Science and Technology in Australia, and I'm presenting the work that my team in collaboration with a team from MIT Lincoln Laboratories have worked on regarding automated business process discovery from unstructured natural language documents. So the hypothesis for our work is that we can automatically discover business processes from the natural language documents that people generate while they are doing their general workflows throughout a day. Things like emails, chat logs, edits to documents, and other types of information sharing and communication channels. So the benefits of doing this kind of research is that it's using stuff that people are already doing in everyday operations, which can help increase wider visibility for the business process modeling processes, as well as increasing opportunities for efficiency gains from that increased information and increased compliance checking and things like that, along with having some contingency planning aspects as well, for things like being able to have visibility of situations like in this email here where two people in a business are communicating to each other about the fact that a portal's down, so they're having to do another process of trying to email each other to get information. So there has been a fair bit of work within this area, within both the business process mining community as well as wider machine learning community. So there has been a number of studies using semi-structured information, including textual data, to generate sequences of tasks and also to try to generate business activities or task information using emails and other textual documents. But we have a missing area in this kind of field of trying to do the full end-to-end, generating full business processes from the bodies of natural language documents, primarily as a data source into that system. So that's where our current research fits in. So we have previously presented on part of this puzzle as well back in 2018 in the AI4BPM workshop. However, we've extended on this work that we presented previously to have that full end-to-end system. So we are generating business process models from the natural language documents, some structured information in there as well, but primarily the information within the body of the documents, along with having our system being a very modularized design. So we can easily swap in and out various machine learning, natural language processing, and other resources as they become available. And so we can also have better insight into what kind of algorithms and systems work best for this kind of end-to-end process. So our algorithm is as follows. So we have an ingestion step in which we take natural language documents and put them in a database. So this can allow for wider documentation, wider documents to be ingested into the one location of various types. We then have some natural language processing elements. So these are a pre-processing step followed by currently a activity classification process and then a topic clustering. This topic clustering step goes into constructing sequences of these natural language documents, which then form a basic business process case. These cases are then clustered together to form our business process models. So to begin with, I'll walk through our natural language processing side of our problem and these pre-processing and then activity classification and topic clustering steps. And then we'll go through some of the results of those and follow through with the following steps of our process. So to begin with, our pre-processing steps. So we analyze a fair variety of different pre-processing steps with the primary aim of this pre-processing is to take your textual information and turn it into a machine comprehensible numerical vectorized representation. So the key step within this pre-processing is the vectorization step, with the other steps being optional steps to help increase accuracy that are then fed into the activity classification and topic clustering algorithms. So for the activity classification, we used a mixture of some classical methods along with some more recent deep learning methods, along with some a generalized language model to try to have a broader analysis of what the different methods are and how they work on our particular data set. We were particularly interested in the classical methods because the data set we were working with had a very small set of data. And in addition, it also had some quite bespoke language. So for that particular set of conditions, it has been found that generally your more traditional methods or classical methods have better results. We then also have the topic clustering method, algorithm processing step. So we also identified and evaluated a variety of methods for this step. So we analyzed these against the Apache Camel dataset. So this has 250 emails that are all labeled with an activity, keyword, and meta data labels. These are comprise 65 business process cases that are a part of 6 business processes. So to begin with, we'll discuss our findings for the activity classification process. So this takes those natural language documents and transfers them into activity labels in the form of a verb-noun pair. So for this, we had an accuracy F1 score of 0.96 for this particular step. And we found that the best performing pipeline had no cleaning step, a unigram count-based factorization, a Z-score feature scaling, and a top K maximum count-based feature selection process, followed by the classification model of a gradient boosted decision tree. So you can see the confusion matrix here. It does a quite reasonable job. There is a little bit of conflation between some of the most frequently occurring classes with some of the lower occurring classes, but this is quite encouraging results. So the next process that can be run in parallel to the activity classification step is topic and case clustering. So this is taking those natural language documents again and generating ordered sequencing of these documents. So the topic clustering I described previously, back when I was talking about the natural language processing pipeline elements, and then it is followed and piped into the process clustering algorithm, which is as follows. So we form initial traces by tracing through identical subject lines with common sender-receiver recipient pairings. And then we join these different graphs together further using documents that have similar sender-receiver pairings on the similar topics within a predefined time interval. So for the topic clustering step of this process, we found the most accurate pipeline. We had no cleaning, rapid automatic keyword extraction, vectorization, term frequency, inverse document frequency, feature scaling, principal component analysis for the feature selection algorithm, and hierarchical density-based spatial clustering of application with noise as the clustering model. So this had a little bit less accuracy than the classification system used for the activities. And so it had an adjusted random index of 0.43 and an adjusted mutual information score of 0.49. It did still, though, present quite reasonable results with that strong diagonal line and the confusion matrix coming out. There is some more conflation, though, in that result. However, this doesn't mean that the end workflows will be highly affected by this. So we're very interested to see whether or not the results of this actually flow through to the end workflows and whether the workflows came through as being reasonable, which we'll discuss shortly. So after this step, we have the following information stored in our database. So we have the date time information, the sender receiver repair information, the subject information, of course, the body of the text as well, the activity tag that we've just generated, and then this case ID of what sequencing it is a part of. So to finish off this process, we need to find what process it should be a part of, as along with identifying the ordering. So for these two final steps, we use HDB scan to cluster the different case, business process cases that we've discovered. And then we use a sequence matcher distance algorithm within that HDB scan to measure the distance between these different clusters. And then we use a frequency-based method to identify the start and end nodes.
Amy, you have 5 more minutes.
Thank you very much. So the results of our processing method, we generated the fitness metrics to evaluate that were introduced by Van der Elst back in 2012. And we also generated the workflow diagrams of these and visually compared them. So for the user support and the bug fix workflow, they were the two most common workflows, frequently occurring workflows for our particular data set. So they're the ones we have visualizations of and discuss in more detail. So for the user support workflow, the fitness metrics came out as 1 for all the combinations of the ground truth instances, algorithmic instances to the ground truth model and algorithmic models. And it had the diagram as shown with the algorithmically generated and the ground truth-based model being the same. For the bug fix workflow, there was a bit more variance, as you can see in the values in this table. So the end workflows for the bug fix workflow are as shown on screen. So there's a little bit more variance within their process, but they are still very encouraging and look quite reasonable. We also evaluated global fitness metrics for the ground truth clusters to the ground truth workflows, and that came out to a value of 0.87. And additionally, we also did the global fitness of our algorithmically generated clusters to algorithmically generated workflows, and that came out to 0.85, which is encouragingly close to each other in values. So in summary, we have presented a full end-to-end pipeline for discovering business processes automatically from natural language documents and their contents. And additionally, we've started a bit of a discussion about how we can evaluate the accuracy of the evaluation framework and how we can properly evaluate these processes and the components that make them up. So we'd like to, in future, be able to extend this analysis to not just be an email data set, but to have combined email and other information sources, and also to be able to use existing business processes and add to them with this kind of information and see whether how that would work. Finally, we'd also like to improve some of the methods that we're using and to make remove the classification process and do a more automated process in there. So thank you very much. Were there any questions?
Thank you, Amy. We have 2 questions, and then I have a question. So we have 2 questions in chat. The first question comes from Massimo Coletti. Massimo, do you want to ask your question?
Hi, I'm Massimo. I hope you can hear me well. My question was if you have started with a blank list of activities, so without knowing anything about the process, or you started with a known list of activities, perhaps as a starting point, and then you have checked or enhanced this list using the analysis of the documents.
So you're saying that we have like a list of the different activities and then you don't have them tied to documents, but you try to identify what they would tie to in the documents?
Yeah. Yeah, if the activities that you were parsing were matched or were based on a known list because you already know what was the process scheme and what were the expected activities to be found, or if it was a discovery from scratch, so without not knowing anything about the activities and looking only at the results from the processing and the analysis algorithm.
So our current research, we do assume that we do have a list of top activity labels that do tie to specific document instances. However, we do want to in the future expand that to being less and less supervised, so removing that need to have that list and to have it just automatically extracted from the document.
Okay, thanks.
Thank you. And our next question is coming from Faria. Faria, you want to ask your question?
Yeah, thank you. Thank you, Amy, for your talk. It was very interesting. I had a question about kind of I guess it would be pre-processing. So when I think you mentioned that you grouped the documents by topic, sender, receiver, and a predefined time range. So how did you decide on the time range to consider?
Yep, so that particular clustering method, the time range, we did have a look at a few different values and found what was the most accurate. And for this particular data set, that was 3 days. But that would be kind of dependent on what kind of work you were doing and how frequently people got back in contact with each other regarding a particular area of work.
Okay, thank you so much.
I also have a question. Can you go back to the pipeline slide, please? Yeah.
That one will do. Yep.
No, the next one. Yes, this one. Can you comment on the difference? Yes. Can you comment on the difference between your approach and, say, Mail of Mine, which is kind of state of the art, as you mentioned?
Yeah. So we lean more heavily on the actual natural language content of the documents and emails in this case, and trying for a more generalized approach to not just be specific to emails, but to be more generalizable to things like chat logs and document edits and things like that.
Great, thank you. I don't think we have further questions from the chat room.
So I guess we can close the paper session. Thank you all for attending, and thanks to the speakers, and big applause. And I guess we're moving now to the closing, right?
Yes. Thank you. So I share my screen. Okay. So I tried a little bit very quickly to summarize what we saw in this edition of the workshop. So I would like to very quickly to what to the different insights that the papers have given in the context of artificial intelligence applied in the context of business process management. So first of all, Chiara was in the welcome was mentioning a little bit about the percentage of the submissions. Then we went through the reviewing process, and at the end, after the reviewing process, the outcome was giving this distribution of topics. So we had a very good number of papers related to process optimization, still predictive process monitoring, and natural language processing for BPM were also were also among the papers that were accepted. In addition, so what we started with the keynote of Artem this morning, who has had a quite a good attendance. We will see at the end some information about attendance to the workshop. There are two very hot topics that came out from the keynote, that were the topic of goal recognition and robotic process mining, that are quite hot topics in the context of the interaction between artificial intelligence and business process management. But already in the keynote, there were some keywords that were appearing that actually are recurrent, have been recurrent during the development of the workshop, like, for example, explainable AI, forecasting business processes, automation, and so on. So there are quite some points that have been highlighted throughout the entire workshop. So, for example, we started with the first presentation where again, the term explainability is becoming more and more popular in the context of predictive process monitoring. Then another very important topic in the context of business process monitoring is the use of intercase features together with intra-case features. So the importance of the context for making prediction on the future state of a process. And we saw also the importance of the use of AI techniques in the context of process mining already in the first session with the root cause analysis presented by Manaz, but also in the last session we saw that process mining plays an important role in the interaction between business process management and artificial intelligence. Another important topic was related to resource management, which is actually, I think, in the next future becoming more and more important, I think, in our field. And of course, as also the percentage of accepted paper in the context of optimization, the optimization of the process from different perspectives. And we saw also another application of automated planning that Andrea knows very well, for somehow optimize the execution of a business process. So we saw this tool presented by Tathagata. We saw also this overview presented by Alice about what AI can do for business. So a little bit we went throughout all the possible terms that can appear when we talk about the interaction between business process management and AI. And then again, in the last session, we saw again the importance of process mining, in particular also the importance of having runtime support for people during the process execution, so that somehow the execution of the process can be driven towards a good outcome. And the last two presentations were also related to quite a hot topic in the context of business process management AI, and this is the analysis of natural language information. And the last two presentations were actually related to also an important topic that also was among the ones that were accepted in the workshop with the highest rate. So this was maybe a very quick sum up that I managed to do very quickly during by observing the workshop in the back end. So what to say? I have to thank you for being so many attending the workshops. I was somehow monitoring the attendance over the different sessions of the workshop, and we had very high attendance for the keynote. We had a peak of 122 people there, but also in the sessions we have a very good attendance. Indeed, in the last session we had a peak of 116 people attending the workshop during the presentation of GUNAM. So, and of course, several people were somehow supporting the workshop to make it successful this year. So we want to thank all of them, the reviewers, the session chairs, all the presenters that have been with us today, and all the authors, because we had also a good submission rate this year, also the ones that had the paper rejected, unfortunately. And we want to thank the workshop chairs and the local organizers who supported us with the development of the workshop. Okay, the attendees is something I refuse here because I already mentioned it, and we hope that next year we can have a successful workshop as well, and we hope to see you in person in Rome next year. So thank you very much. So I think we can close the session, and again, see you. Bye.